14, right. So circle C1 as centre A in this equation. So on the coordinates of the centre and the radius of C1. So I need to complete the square. So I group the x with the x squared and the y term with the y squared. So to complete the square here then, half of 6 is 3. It's going to be x plus 3 all squared. And I got a plus 9 at the end there, so I subtract 9. And then half of minus 20 is minus 10, so that's minus 10 squared. And I got 100 at the end, so I subtract 100 plus 59. That's not. So write in the standard form of the equation of circle equals, that's 100 minus 59 plus 9 and so that's 109, take away 59, that's 50. So the centre, which is the coordinate of A, change the signs of the brackets then, so that's minus 3, 10, and the radius of C1, that's the square root of 50. 2. Find the shortest distance from the origin to this circle. Give your answer correct at 2 decimal places. Okay, so if I just draw the sketch here to see what's happening. Circle, it's the centre A, and that's at minus 3, 10, so the axes will go something like that. There's the centre. And I want the shortest distance from this origin onto that circle. Well, if I join the origin to the centre of the circle, then that distance there is the shortest distance. So taking that to the centre, A is minus 310. So if I work out the distance of minus 310 from the origin and then subtract the radius, and that will give me the shortest distance from the origin onto C1. So distance of away, that's the square root then of x2 minus x1 squared plus y2 minus y1 all squared. Square root of, that's just minus 3 minus 0 squared plus 10 minus 0 squared, so that's 9 plus square root 10 squared is 100, that's equal to the square root of 109. So the shortest distance from the origin to the circle C1 is that distance, root 109, take away the radius of the circle, which is root 50, and I want this answer to 2 decimal places. So square root of 109, take away the square root of 50, and that's 3.369238697, and I want that to 2 decimal places, so that 9 will increase to 6 to 7, so that's 3.369 3, 7. Okay, part B. I got a line L as equation y equals 3x minus 1, and this is it's intersecting circle C1 at P and Q. Find chords of P and Q, right? So to find where they intersect, let's solve the two equations simultaneously. Okay, so replace where I see a y, replace it with the bracket 3x minus 1. So that's x squared plus 3x minus 1 squared plus 6x minus 20 times 3x minus 1 plus 59 0. Expand the bracket then, so 3 terms, square the first, 9x squared, multiply them together and double it, so that's minus 3x doubles, that's minus 6x, and square the last is plus 1, plus 6x, minus 20 lost to 3x is minus 60x, minus 20 times minus 1 is plus 20, plus 59 equals 0. So that's 10x squared. Right, minus 6x plus 6x cancels out, that's minus 60x. Now you've got plus 1, plus 20, plus 59, so that's plus 80. Equals 0. Divide by 10. X squared minus 6x plus 8 equals 0. That will factorise. X and x. 2 4s are 8 and they add up to 6, that's minus 2 minus 4. So x is equal to 2 or x is equal to 4. If x is 2, then y is going back into that equation, and 3 2s are 6, take away 1 is 5. And if x is 4, then y is 3 4s are 12, take away 1 is 11. So P, doesn't matter which way around these are, P is 2 5 and Q is 4 11. That's part 1. And then part 2, circle C2 has the centre 6 7 and it's such that PQ is a common chord of C1 and C2. So if I draw two circles and they obviously intersect, just get a sketch to see what's happening. One circle, change the radius. Another circle. So this one is C1, this one is C2. So for C1 centre is minus 310. For C2 tells me the centre, that's a centre B is 6 7. And PQ, these two coordinates show is the common chord. So the common chord is that line there, and P is at one end, so 2 5 there for P, and Q is the other end at 4 11. And I want the equation of C2, so I go to the centre, so it's going to be x minus 6 all squared plus y minus 7 all squared equals the radius squared. Now to get the radius, if I join B to either one of these two, either to P or to PQ, then that is the radius, distance from the centre to circumference. So if I work out the length of BQ, that's the radius of my circle C2. So to find BQ, that's the square root of that, so B 6 7, Q is 4 11, x1 y1 x2 y2, so the square root of 4 minus 6 all squared, add 11 minus 7 all squared. So 4 take away 6 minus 2, square minus 2 is 4. 11 take away 7 is 4, 4 squared, 16. So BK was the square root of 20. So the radius is the square root of 20. So for my equation of the circle then, the radius root 20 is root 20 squared. So C2, the circle is x minus 6 all squared plus y minus 7 all squared, and square root 20 is 20.